everyone, we're going to find the sum of the telescoping series 2n plus 1 divided by n squared times n plus 1 squared. The first thing I want to do is break this up with partial fractions. So we have 2n plus 1 divided by n squared times n plus 1 squared equals a divided by n squared plus b divided by n plus 1 squared. Clearing the fractions, we're going to get 2n plus 1 equals a times n plus 1 squared plus b times n squared. Now let's let n equal 0. If n is 0, then we're going to have a equals 1. And then let's let n equal negative 1. If we have a equals negative 1, then b is going to equal negative 1. So now I can write this as my sum from n equals 1 to infinity of 1 divided by n squared minus 1 divided by n plus 1 squared. All right, now that I have that, we can notice the telescoping series and see the pattern a lot better than if we left it like that. So let's go ahead and do that. I'm going to rewrite it real quick. I'm just going to write this as 1 divided by n squared minus 1 divided by n plus 1 squared. Now, for our first partial sum, that's going to be 1 minus 1/4. For our second partial sum, that's going to be 1 minus 1/4 plus 1/4 minus 1/9. Now this is going to equal 1 minus 1/9 because of the telescoping nature of our series. And then let's do our third partial sum. That's going to be 1 minus 1/4 plus 1/4 minus 1/9 plus 1/9 minus 1 divided by 16. So this is going to be 1 minus 1 divided by 16. After doing 3 of these, we can get the nth partial sum, and that's going to be 1 minus, they all have 1s in the numerator, so that's going to be 1 divided by, and these are going to be n plus 1 squared. All right, so when you look at your trying to find the sum, that's just going to be the sum equals the limit as n approaches infinity of our nth partial sum given here. Now, as this goes to infinity, as this number gets larger in the denominator, this is going to go off to 0. So our sum is going to equal 1. All right, because we're just going to have 1 minus 0. Thank you. Have a nice day. Bye-bye.